Hi there, and welcome to this third video in the series Learning SolidWorks. My name is Raz, and in this video we'll be finishing the remaining parts for our Lunar Orbiter project. You'll learn how to create more advanced parts, we'll work with configurations, and we'll wrap up with a quick introduction to SolidWorks Visualize, which comes included with the SolidWorks Maker license. If you missed the first two videos, check the description below for links to those videos. Before we get started, I just need to mention that none of these videos are sponsored by SolidWorks or Dassault Systems. The opinion that I express are fully my own. And lastly, if you don't have SolidWorks already, please check out my other video on how you can get SolidWorks Maker and get started. All right, we're back in the project, and one of the first things to do before we go any further is just to make a sense of scale. So we talked about this in the first video, but we didn't really do anything until now. But basically what I mean by that is we need to dimension our whole assembly to something that we expect in the real world. So we said that we're gonna do something like 185 in diameter cylinder and about 300 tall. So let me just show you how to do that. We simply just create a new part there, and let's just do it on the top plane. And we say here, we want it to be about 185. So this is just like whatever you think that it should be. And let me just say midplane should be about 300 millimeters tall, let's say. So this is what I would expect that the lamp should fit inside this volume, kind of. And I'll just close that, and then I'll just rename this for space envelope. So this is just like a visual guide for ourselves to say this is what we're designing for. It should fit within this. And we can see now already that it's probably going to be too tall, but let's try to just move this around a little bit so it fits, let's say, there, there, and let's just move it about to there. So we can already see now that it's going to be too tall. So let's just try to just hide this for a second, and let's adjust this. Let's say instead of 185, let's just try 165, 155, something like that. So we took off about 30 millimeters, and so we'll just do the same for this part. And here you can just write minus 30. There. So now we've adjusted that, and this is a good way to like adjust your parts in the assembly context. So you can make it a rough dimension, and then you can always fine tune it to your final design. All right, so now let's move on to designing the landing gear and the flame. So before we get into designing it, let's just have a quick look at how we would draw this up. And obviously I've drawn this already, but in your case, you might be designing a new product and you have a sketch or something like that. So try to just do a few sketches until you're kind of happy with where the design is going. So for this one, let's try to analyze it for a second. We have a round part, and it has 3 legs, and it has kind of like a shape that's kind of repeated around the circumference of the part. So if you kind of like, if you were to take like a cross section of this part that goes straight through one of the legs, you can kind of see that it goes down, and then you have a sharp point and it goes up again. You have some sort of curve, comes down, and it meets some sort of flat point which sits on the ground, and then some sort of flat point that goes up, and another curve goes up, and it meets the kind of cylindrical shape up here. And our flame, it's kind of, we want it to be part of this part in a way. And this is one way to show you how to do split parts. So we'll get back to that later. So let's get into it. All right, so we've created a new part here, and let's start with sketching on the front plane. So we know that we have some sort of round shape, right, a diameter, and we also know that it needs to go down into like a point where the flame is in a way. We also know that we want to have like some sort of flat part out here on the table and a flat part that goes up. So something like that. And SolidWorks, when you just draw like this, it doesn't have a sense of scale. So the first time you put a dimension on it, it'll actually scale all the other stuff. And that can be quite useful. So We said that the diameter of it should be about 185. So we'll take this one and we'll just say, so the radius would be half of the diameter, like that. So now you couldn't really see what happened, but it actually scaled all of the rest according to the dimension you just put in now. And let's put a few dimensions. This, let's say 3, and let's say 2. And let's say this should be the dimension from where it kind of interfaces with the other part, and the floor should be about 65, let's say. And then let's say up here we should have about 10 millimeter of kind of like part that comes down from the other part. And let's say that the diameter of this up here, I think we said 45 was the diameter. So we'll say like that. And now we only have one point here that's not defined, but we need to obviously have some sort of curve coming over here. So let's try to just use a spline. Let's just try to do directly like this. So splines work as a line with some control handles. So these control handles you can like move like this. And for this control panel, I wanted to kind of come down and meet this line. So let's try to click on that and click on this control handle. And we'll say that these should be collinear. And then it's way too curved here. So we'll just wind that all the way down like that. It doesn't have to be accurate. You can play with this later as well. Let's say something like that. And let's say this one has to go up first somehow and come down here like that. Actually, I'll just delete this point here and we'll just remove the handle instead. So something like this. So I don't know if you can start to imagine it. If this is our rotation axis, this will be kind of like the leg shape. Something like this. So again, we can just have a ball pack for now and then we'll come back to that later. Let's say about 50 for there. And you notice the handles here are still blue, and that's okay because like you can adjust them and it's kind of hard to define. Like you can define it with the length and stuff, but it will be kind of arbitrary. So I find that when you work with some curves that are hard to define like this, you kind of just visually look at the shape and adjust. If you're working with a project where you really want to define it, I would use like a style spline because you can then adjust the length and the dimensions of these like guide lines. But yeah. All right, so now let's try to resolve this. So now it found a line, but it's not the right line. Let's say we want this instead. Okay, so now we have like some weird kind of shape, right? But we can use this. And we only wanted 3 legs. So we can do cutout for the rest of the material we don't need. So let's try to sketch on our top plane here. And I want the end of my foot to be kind of like round, like this in a way. And we'll try to draw in like the shape of the foot as seen from above. We'll also use this center geometry as a guide. So we'll say that this should be co-radial with this. And let's use a spline for this here. We'll say something like this. And this one, this handle here, we want that to be tangential to this. You see this snapped away from this, but we actually want this to be in contact with the outer radius here as well. The diameter, sorry. So co-radial. Nope, that's not it. We want it to be tangential. Now it's starting to get messy, and that's because we're not controlling it properly yet. So we need to have some sort of control on this circle up here. So I'll use a center line and just get that into the center there, and we'll say that's vertical. And let's also give this a dimension so it knows. Let's say 10. Yeah, it doesn't have to be much, just like that is fine. And then let's say this handle should be something like this. Maybe let's try actually just to make it vertical. Yeah, that's all right. And then we'll mirror this one to the other side. This, and now I can kind of start to see the shape of it. I think it's looking a little bit wide for now. Say something like this, maybe something like that, a little bit sharp. And now we see we don't need these parts of the circle, so we can trim that away. And then we also, so actually before we, yeah, let's try to copy this around because we wanted 3 legs, right? And let's try to do a circle pattern and 3. So now you can start to see that it looks like something. Let's click OK. And let's try to imagine we're cutting away material, but we want to cut the material that's not within the envelope of the shape, right? We don't have an enclosed shape just yet because we have a line that kind of goes through here. So let's try to remove that. Let's try to remove this. Trim it, trim it, trim it. And now you see you have an enclosed shape because it changes color to blue. And let's try to now do our extrude cut. So let's try to go through all, and this is kind of opposite of what we want. So we'll do a flip side cut. And okay, so there we have it. That's the basic shape of our foot. And now let's try to clean it up a little bit. So we can put in some fillets here. Let's also try to build in some fillets here. I don't mind these being fairly big, so it kind of blends in with the other geometry. And let's try to see if we just select the face here and select a small radius. It'll select all of the adjacent edges. Oops. If you find that it kind of selects lines in the back, what you can do is you can hold in Shift, and then it'll select, it'll force it to select whatever's in front. And that's a good tool to sometimes, if you have a lot of lines in the back. So just change that to 3. Now let's try to turn off this so we can see. So it's starting to look all right, but I don't know, it's a little bit kind of not so like natural, the shape there, I would say. And one way to kind of analyze that is, let's go back to the sketch here. And let's go to this curve, show curvature. So here, this is a good little tool to kind of tell you what's the actual curvature of this spine is doing, or what is it? Yeah. So you see like it gets sharp when there's like a very abrupt change in curvature, and we want it kind of to be smooth. So do something like this. Can also something like that. Not sure like that. But yeah, that's one way to play with it as well. Something like that. All right, let's try to also get these down here. You see it kind of breaks our little like flat bit out here, but that's okay because it still touches the ground at that point we want. And we're getting a smooth kind of rounded edge there. So this is starting to look all right, I think. Now this point is very sharp, and that's probably going to be very hard to produce. So let's try to smooth that out a little bit. Let's say we want like some sort of like a radius here, but should be small. So let's just delete this one for now again. Let's backtrack a little bit. Let's say it should come down, meet a tiny little circle, maybe just 1 millimeter, maybe 2, 1.5, something like this. Let's try to use the spline again. Come over here and make this one now tangent to this. And let's try to delete this one, get more natural flow of the curve. Something like this. And now let's try to delete the stuff we don't need. Something like this, right? So now it comes down and joins like a more like smooth kind of circle. And that's going to be more easy for the tool to actually do. Now we got an error because we changed this, we changed the like lower surface, and now I can't find that surface anymore that we referenced. So let's just fix that. Let's clear that. Select it again. And there we go. Now it's not as sharp there. So let's just proceed to save this before we go any further. Okay, now let's proceed to bringing in our landing gear here into assembly. Let's say this has to be made it concentric to this. And we want this surface to match here. And let's just make this parallel to the front plane so that now it's fully defined. You can see already the lamp is getting too big, but we'll adjust that in a second. For now, we'll just hide this. Another way you can hide it, other than just going up here, is to just hover your mouse over it and click tab, and that hides it. And if you click shift and tab, it'll bring it back. So it's also a good way to work with your model if you're trying to yeah, just look through it. Okay, so let's have a look at how this part would interface with the next part. You can change the transparency here, and now you can look through it. And we said we wanted to have something like a press fit kind of thing that comes up and fits into this kind of cavity. So let's try to draw that up. Let's go back into the part. And let's just make a center line first. And let's try to create that. So we know that the wall thickness of the other part was about 2, I think. So let's say it should be about 2.1 here, just to leave a little bit of space for the parts to actually fit together. And let's try to do something like 2 O-rings that sit around this and it fits up into the other part. So I'll just need a little bit more space for that. Let's say have something like 2 O-rings sitting there, right? And let's say a diameter of 2. Let's make them equal. And now let's say the distance between them should be, let's say 5. And let's try to find a distance from the edge here, say 2.5. And let's try to define a height here also. About that. And we just need a groove for the O-ring to kind of sit inside. But actually looking at it now, this wouldn't really fit right because it would be too much interference with the part here. Let's try to redraw it. So I'll bring them back a bit. Let's say the O-rings would be 2 in diameter, so we'll just do 2.1. And we want it to just come out our wall is at 2 exactly in thickness here. So that's there. So we get about this much kind of interference, and that looks about right for the O-ring. So let's do that here, 8.5. And now we want a groove for the O-ring to sit into. So let's draw that groove. And there we have like a groove for O-ring. Let's do the same for this one. And you can see that they're blue, so something is missing. It's because it's lost the dimension we gave it because we cut out that. And we'll just make these two equal. There, let's see what else makes it missing. So it's missing a distance between them. Let's say 6, and let's say that this has to be about 2 from the top. And so now they're fully defined, as you can see. And to make it easier to have the O-rings kind of come in there, we'll just remove these sharp corners here. And probably about half is enough. You can see how much it is if you change it up here. I assume that this part is 3D printed, so anything like this is easy enough to make. So like that, and we still need a line in the bottom to our center of rotation. And now let's try to revolve that. And this axis if it's close, and we'll select this axis. So there we have like an interface with O-ring grooves. Round off this top as well. 5 is enough. And this is obviously still like solid, and we want to cut away a little bit of the weight here, but we want this down here to be our flame part in like a clear plastic. Let's first try to remove a little bit of material just for weight reduction. Say 30 is fine. Actually, instead of doing that, we'll just say that it should be some distance from the edge there. And let's say 30. Yeah, 30 is about fine. And let's just try to put a chamfer there or something like that. So now we've cut out a bit of the material, and it kind of starts to look a bit nicer. I'll just put it around, put it there. One way to look inside is to go up here and kind of see like that. So a part like this should be able to be 3D printed very easily. And let's try to change the material. Something like that. I'll just save it. Okay, now we are back in the assembly, and let's have a look at how this looks like. So yeah, it looks pretty good, but we have some interference here, as you can see. So we need to make a few adjustments to our model overall. If we bring this back, you can see that it's too tall to what we wanted. So we have a few options. Like we could make the landing gear lower, but I kind of like that it kind of hovers like this. We could make the control panel lower, but it would kind of compress the buttons and make it a little bit more difficult. But I think there's room to compress it a little, so let's have a look at that. And then of course we can compress our LED panel, and that's just a trade-off. So you have less LEDs, but I think that'll be all right as well. And we can make this one shallow as well. And I think we could maybe take a little off, but it kind of looks nice as it is there as well. So let's try to start with the LEDs. So let's hide this. And let's try to go down to 135. I think we took 20 off there. And let's try to go into the other one again. Took 20 off. think that looks all right. And now let's try to reduce this. That's not gonna work. Let's try 55 actually. We just need to fix our pattern mate here. So let's just get the dimension of this. That's now 12. Oops. Collapse that. So that's actually acceptable, I would say. And now we also can fit in the bottom there. Let's see how that looks now. So we still have a ways to go. So at this point, it's kind of a trade-off between the initial guess or how we would like the lamp to look like. And I would say it doesn't really matter that it's a little bit taller. I think I would rather have it a little bit taller and look well proportioned. So let's say that we keep it like this. Now let's try to move on to split parts. So split part is when you have like a part like this, but you want it actually to split it into two parts. And in this case, we were saying that we want to have the bottom kind of be like a clear plastic so that we can have a LED inside that shines through and it'll look like a little flame. So let's try to do that. Let's move into this part. And split parts you find up here in features, split, and it requires a drawing or sketch to work. So you basically can think of it like a knife that you cut through with the part. So let's try to think about this. We wanted to kind of like cut through from above in a circle. So that's exactly what you do. We just move to the top plane here and let's draw a circle. Let's say we actually want it to be the same as this circle we cut here, so that later we can glue it in place. Radial. And I'm kind of regretting the fillet I made there, so I'll just go back and change that because that's gonna make a funny geometry when we split the part. So by clicking twice, kind of like slowly, you can rename it. Split line. And let's click on that and then click Insert Features, Split, and Cut Part. And it'll come up like this and it'll show you where it's found potential split lines. And I would say that's about kind of what we want. Like we want the bottom to be clear plastic here and the rest to not be. So let's say we want both of these. And this one, rename it the flame. And this one we'll rename, let's say, base. And then just click OK, and it'll go through and save those parts. And so when you make a split part, it'll create new physical parts, which are derived from a master part, so to speak. And it might ask you this, like which unit of measure do you want to use? And just click yes, but you can change that later. So now we have it. So this has now become our master part. And now we have two sub parts. So let me just hide this and let's go back to our assembly. All right, so just between takes here, I've already went ahead and drew up this button, and I'll leave that for you as an exercise to do. You should be able to do that by now. It might be a little bit difficult, but try to take your time and walk through the features and see if you can do it. I will show you quickly how like the steps are, but try and go ahead and do it yourself. Extrude, fillet, and you can pause the video if you need to. All right, so let me show you how this mates. So you can do a elongated hole mate as well. If you go in here, select these two, start it there. And now let's say we actually want this to be moving in and out. Let me just correct this actually. Instead of a slot, we'll just say that it's concentric there and concentric here. And now we want this button to be able to be pushed in and out. So we want it to move like kind of like this at a range. And you can do that with the advanced mates. So select the surface in here, select the surface, and then over here you can say a limit distance. And we say the smallest distance it can be is 0. And let's say we have actuation length of 1. Click OK. And now when you try to move it, you see it can only move 1 millimeter. So that's kind of how it will be in real life. And this helps you kind of analyze how the parts will move in real life and if there's any like conflicts with other parts and so on. Now let's talk about configurations. So we just made a foot with two parts in it. So we have a clear plastic part and we have a normal plastic part. So the part we have in here now is actually our master. This is the one that we split. Now we have the two new parts we want to put in here. But let's say we have two models of this lamp. We have one which has the flame, the clear plastic, and we have another one which has this foot or another foot, for instance. Or we have another one that has different colors or different dimensions altogether. You can handle that with configurations. So let's say this is our no flame version. So you go up here in configuration, and these are the different configurations. So you can have master configurations and you can have child configurations. So let's say you have a configuration which has certain color, but that one has a different landing gear or so on. You can kind of make them related to each other in this way. But here we'll just say it's completely new because it'll have a different foot. So we'll say with the flame. Okay. We can go in here and say okay. So configurations work with like states of the part. So if you have it suppressed or you change the material, so stuff like that. So let's try to put in our new foot here. So this is the one with the flame. And we say we don't want this one to be in this one. So we'll suppress that. And you can't delete it because it's still needed in the other configuration. So let's go have a look at the other one now. So in this configuration, it's not suppressed. But if we go back to our flame, it is suppressed. And now let's insert our landing gear. Oh, sorry, base and flame. I'll just put them here. And we'll give it the same mates as before. Concentric. The surface mates with the surface. And we'll just say that this is front plane to front plane. And this one. So you have multiple options here. Because this part is derived by this part, they will have the same origin. This origin and this origin. So you can just make those two origins in this case, and it'll come back to that. And now let's go try to change our flame to a clear plastic. Clear, let's say it's frosted. And now let's go back to our other configuration. So in here, it's actually insert this new parts here, but we don't want those in this configuration, so you can suppress those. And now when we swap between these configurations, you'll see it looks more or less the same because it's more or less this, but it actually, it suppressed the landing gear in this one. And in this one, it suppressed these new two parts we put in. So that's how you can work with configurations. Let's quickly cover the assembly process. If you remember from the first video, we talked about we wanted a threaded rod to go through and hold it all together. So let's try to draw that up really quick. Create a new part in our top plane. And let's say it's a M4 threaded rod, let's just say. So 4mm. Let's see if 200 is enough. Let's say 250 for now. And let's just go back here for a second. So I wanted this threaded rod to screw into the top here. It's drawn in place. Let's quickly talk about axes for a second, because this is a round part and I want it to be in the center, but I want to be able to drag it up and down right now while I'm thinking about how I interface it up there. So you can click two planes, for instance, and these two planes will intersect at a certain line in space. And I want to define that line as an axis that I can use. So you go up here and click Reference Geometry, Axis, click OK. So now in my assembly, I have a center axis. Now I can use this axis to define that, let's just click View so we can see. There, center axis. I want to define my center rod to be on this axis, concentric. So now when I drag it up and down, it'll follow that axis, but it won't be defined at a certain length just yet. And that's fine, because we need to have a look at this. So yeah, I wanted to screw into the cap here at a certain distance, and I want this to be supported to my cap somehow. So let's just open up this one. So we need to create some sort of surface, mating surface up here. So what I just did there was click the top plane and I hold in Control while I drag. It'll create a reference plane. Yeah, and then we'll just, let's see, we want to see it from the bottom so we can see what we're doing. And let's just create a, something like 20mm will do, and extrude. And we'll extrude until next. So this will extrude this circle up until it meets geometry, which is what we want. There, now we have some material we can use for threading our threaded rod into. I'll just put a fillet here to make it easy to machine. And I'll just round this off as well. One. And now let's talk about the hole wizard. So hide this well. It's up here. And this is useful for whenever you want to create a hole that's specific to threads or screws or dowel holes or just standard drill holes. Anything special, basically. In this case, we want a threaded rod. So we go up here and click straight tap. So you see here you have a kind of counterbore screw or countersunk, or this is just a normal hole for drill, and so on. So these are very useful. And you have different standards here for the different fasteners. I know that I want to use a DIN, and it's a tapped hole, bottoming tapped hole, and it'll be a M4. There, and in position, I want it on this surface, and I just want it in the center. So I'll give you this here. And basically, it just uses the point in the sketch. So if you were to click escape here, if you just click point again, it'll come back and it'll do a new hole there. And just a tip, if you drew a rectangle consists of a point at each corner and in the center. So it'll actually treat that as you want the holes there. So that's just something to be mindful of. If you didn't want it to do that, you'd have to delete the points and so on. So just if you encounter that and you're wondering what's happening. Now go back and let's see. We don't want it to go all the way through, obviously. We want it to just have some depth. Let's say 15. That looks about right. And 10. So this is the depth of the hole, and this is the depth of the thread. And usually you want about two times the diameter. So at least, so I'll choose 10, that's fine. And it automatically creates a chamfer for the hole, which in manufacturing makes it easier to tap the hole. You can control that down here. Okay, so let's save this and go back to our assembly. And now you can see it's gone, and that's because you just need to refresh. There. So we just need to move it back a little bit. Let's do that. Let's first measure how far back. So I'm holding down Shift to get this surface here, and Shift, hold the surface, and go up Evaluate, Measure. So 4 millimeter. We need to move this back by. It's kind of hard to see where that dimension is, but we can just go in here. Oh, it's hiding in there. So yeah, we drew it from a plane, so we need to move the plane 4 millimeter. Like that. And I want to have the end of this threaded rod about 10 millimeter into the thread. And it's kind of hard to get in and hit the surface now of the cap. So what you can do is you can use isolate. So you just click this and you click your threaded rod. So the two things that you want to view just now, you right click and click isolate. So that'll just isolate the whole assembly by those two that you've just selected now. So that's how you can work in an assembly context with just a few parts and make it easier to manage. So I'll select these two surfaces and say I want it 10 millimeters in, but the other way, like that. And now you can go out of the isolate again. So now you have it go through there. And we see here there's a conflict. Let me show you something. If you at any point want to check if there's a conflict like that, we already saw it up there that this part interface is interfering with the threaded rod. You can go up here and evaluate and click interference detection and click calculate. And it'll go through and see, okay, where do we have interferences? So that's interesting. It's pulling up all these, and that might be because yeah, so that's because of this, because we've made a space envelope. Let's suppress that for a second. Let's try again. So now we see there and there. So this interference, it's saying that we have interference in the top cap and with the threaded rod. And you can see that here, these two parts. But that's normal because you want that material be like drilled out when you actually do the thread in real life. So that's okay. And it also says we have between these two parts. So that's what we saw before. You can use this tool to find out any mistakes or interference that you might have made and you might not have seen. So this is a very important tool to analyze your design. And now let's try to see these two parts here. Let's just rename this first. Trade rod info. And I want to see this and the plastic part that we want to work with now. So I just select these two and then click isolate. Now we can see here the threaded rod is interfering with this part. So let's make a hole in this one. Click edit. And we want it to be, actually, let's just go back from this one. And let's say we want actually to have a M4 clearance hole. So we go up here in hole. and DIN, and we want a screw clearance of M4. So what it does here is it automatically has tables of hole sizes, which are standard. And so it saves you a lot of time trying to look up tables and so on to find out what should the hole size be for M4. Just knows. And you can go in here and click which tolerance you want, like if you want the hole to be really close or if you want it to be very loose. That's how you decide that there. But this would be a hole that fits M4 with a normal kind of tolerance. It goes through all of the material, which is fine for now. So now we have a hole for this part. Click exit and just collapse this. And let's try to run our interference detection again. And now we only have this up in the cap, which is fine. So you can just click ignore if you want. Great, so now let's have a look at it again. So the thread rod is now threading into the top here, and this one meets the part here, and this part meets the outer cylinder in this joint. That's fine. And it goes down here and meets this joint, so these are compressed. So maybe actually you would want to leave a little bit of space between these two parts so that when you are compressing it, it'll compress the outer shell here also. But yeah, that's engineering thoughts. So now we need some sort of surface here to actually put a nut on it so we can tighten all together. So let's try to isolate these two parts now. And now let's try to go into this part. So I want to have kind of like a surface where I have a hole in it where I can put a nut on the other side. Let's just go back here a second. And let's have a look if we can actually fit that down there. So we could fit that if this was a little bit smaller. So let's just try to do that. I'm going back and forth a little bit, and that's how the design process is. Sometimes you need to tweak things to make things fit. So let's just ignore that for a second and go back to this. And now let's try to edit this part. Let's make a plane around there. So I click the top plane and hold down Control and drag and then 30 millimeters. Now I want to use this geometry for my new sketch. So let's do a new sketch in here. It normally takes you to the normal of the plane when you're drawing by default, but I like to kind of draw in 3D sometimes. And let's see if we can get this surface in here. Intersecting curve for this. There, so it's found that circle there. And let's try to say we just want to extrude that up by 1.2 should be enough for now. Yeah, we could have actually drawn the hole there at the same time. If you know what the hole size is, you can also just do it like this. And this is M4, so we'll just say M4.2. And whenever it disappears like this, just refresh and see if it will come back. Usually it does. And we'll just fix this up a little bit. Say 2 millimeters like that. That's good. Now let's exit this and exit our isolate. Let's go back to our part here. So now we have a threaded rod that screws into the top, the parts go together, and we have like a base down here. So if we put a nut here and screw it together, it should hold all the parts together, which is what we want. And that leads me to show you Toolbox. So if you go over here, it'll look like this when you first open it up, and it'll have something called Toolbox. So that's basically a place where you can get all kinds of fasteners and stuff like that, and it's very useful. I usually work in DIN, and let's try to bring in a nut for this threaded rod here. So X nuts, looking for just a standard bulb, but you can find whatever standard fits you. Just drag that in. If you don't see it like this, it's because we are in a section view. When you drag in new parts in a section view, it won't show them until you refresh, or if they're on the other side of that section view. So let's just go back to scratch for a second. There. And it should be a M4, so we can't do that with that standard. Let's try to just do normal ones. So this one has M4. And you can also add washers and all that kind of stuff if you want. So now it's kind of hard to see right in there. So again, let's try to use our isolate. So we'll take that. So sometimes it'll bring in the part at a very weird location like this case, and sometimes you even lose the part. So a tip for that is just bring it back to origin for a second, like made it with origin, and Control 7, and it'll usually pop up there, and just delete that again. So then you have it here where you need it. So let's make this to there. Get this, because we want the surface to be on the bottom there. And now we can edit this even in this view. We don't need to see the rest of the part for that. Let's say hidden in here. Let's say 240. And Control Q to update. It's about enough. Maybe 245 in real life would be better. Okay, exit. Right, so there we have it. We have the assembly process also implemented now. Okay, okay. Okay, so before we export this to SolidWorks Visualize to make some renders, I'll just want to add a LED panel so we can use that in our actual render. So let's start by just isolating this part we want to work on. And I want to create a new part here, which is a LED panel that goes around the circumference. Let's click a new part here and just make it on this surface. And we'll just use this circle here as a reference. Convert entities. And we want it to be split. So like we want the LED panel to be split by some gap. So I'm just drawing up the gap I want to kind of cut out. And let's say it's 5 degrees would do. And I want it to kind of be in the middle of this. And let's make these into construction lines in a second. We'll just cut out these two here. We'll make this to a construction line. There, so now we have a circle that doesn't go all the way around, but it kind of is cut in a section. And we can use this to extrude a surface. So you have a tab up here called surfaces. If you don't have that, you can click right click on here and click tabs and surfaces. And here just extrude. So a surface doesn't require a closed shape, it just requires a line, and we have that here. Let's just write a number and see what it looks like. That's too much. Something like 130, that's fine. So now we have a surface, we can actually thicken it. So we can thicken it in the outer direction. Let's say elevator, sort of like. So this would be like a flexible PCB kind of LED panel. So it's about 0.12 in thickness. And now let's try to add a LED to this. So I'll just open up this part for its own. This is how we have like a little panel, just around these corners. Let's say 2 millimeters. And I'll just click this one because then it'll take the other way. Yeah, so I'll take the other side. About 1 is fine. Okay, now let's try to make an LED. So I'll just create a surface that's tangent and parallel to the front plane. And let's try to just draw one here. So we'll probably be using something like a 50-50 LED. So that's 5x5. And let's just make that centered there. And let's say that it's about 3 from the edge. Let's extrude this. Let's say it's about 1. And then direction 2 up to the surface. And let's try to just draw a little LED in here. So I want it in the middle, so I'll just draw some guidelines here. Extrude that. Let's hit 2. And sometimes it doesn't select, even though you have drawn it. You can use this selected contours. And say blind to there. Now let's make this our LED. So we go up in appearances and click lights, LED, white. And we'll make this one a black kind of plastic. Maybe a lot more like a cream color kind of plastic. And we'll make these surfaces like a soft touch green, kind of like a PCB. And we will then pattern these radially. Say 10, 8. Let's pick a uneven number so that we have them kind of like that. Let's add it up a little bit. 18, that's too much, isn't it? 15 is too much. Let's try 13. And let's try to pattern these down the length of it. Use the scroll wheel here as well. Something like that. And actually I changed my mind about the color of this, because once we make a render, you might be able to see the green through the glass. So I'll just make it soft white instead, which will help with the diffusion. Okay, and save that and click OK. Click OK, and exit isolate. Now we have some LEDs that we can use in our render, and I'll just rename this to our LED pattern. Panel. And yeah, as an exercise for you, you can create a little PCB in the bottom here that has the flame LED. I'll do that now, and then we'll have a look in the render how that looks like. So if you have a SolidWorks Maker license or SolidWorks Premium license, you also have SolidWorks Visualize included. And SolidWorks Visualize can make really nice renders such as this, which are really useful for presenting your product. So we'll have a quick look at how to prepare for doing it, and then in the next video we'll have a look at how to actually do the renders. So if you go onto your 3D Experience platform, just go up here in Apps, and you can scroll down, and you'll find Visualize down here. You can also access it by just writing up here, Visualize, and it'll come up as an application. So when you launch it, you might have an error just like me. I was not able to launch 3D Experience for some reason. I'm not sure why, but we can still use it by just making our project local for the render only. So I'll show you how to do that real quick. So we'll just save a logbook copy that we can then open up in SolidWorks Visualize. So just click Save as New. And this is fine. We'll just use it temporarily. And we'll save it here. And then just click here, include all imported reference components, because then it'll save the whole package to this folder. I'll save that. And then when you go back to Visualize and click Open, you should have something like SolidWorks assemblies over here. That'll make it easy to find your assembly. And just click Open. And so this is just asking you, do you want to include some of the things that are within the SolidWorks file, such as the environment, background lights and stuff, and just click OK, because we can change it later. And there you have it. So that's the model. And in the next video, we'll have a look at how to set all of this up. Thank you so much for sticking with me through this video and the series so far. I know it's been a bit of a deep dive, but I hope you've learned a lot and you're starting to feel more confident creating advanced parts and assemblies in SolidWorks. In the next video, we'll take it a step further and look at how we can create some really great looking renders in SolidWorks. If you found this helpful, please consider subscribing. It really helps the channel and it helps me create more content like this in the future. Thanks again for watching. My name is Raz and I'll see you in the next one.